There come times when we want to convert some measurement between systems. So from the US system to the metric system, or from the metric system to the US system. And in that case, we need to look up the conversion rate. We need to look up the equivalences. When we go to do that, we'll find a table that looks something like this. And now there are a couple of things that I want you to notice. The first one I want you to notice is that we have a US to metric table and also a metric to US table. And they've both got all these kind of awful decimals in them. Only one of these is an exact equivalence. It turns out that 1 inch really is exactly equal to 2.54 centimeters. That simple, easy to remember number is, in a sense, what it means to be an inch. The rest of these conversions are all approximations. And by that I mean they've been rounded to a convenient number of decimal places. So, usually not important, but you should be aware that these conversions are not completely exact. So how do we use a table like this? Let's suppose we wanted to convert 47 pounds to an appropriate metric unit. An appropriate metric unit. What do I mean by that? Well, I'm going to look in my table and I'm going to find all of the facts that involve pounds and just think about them. What do I have? From this table, I have 1 pound is 0.45 kilograms. And from this table, I have 1 kilogram is 2.2 pounds. And it looks like that's it. So kilograms are my only choice for a metric unit to convert into. But I have two different conversion factors. And because they're rounded, it matters which one I pick. I'll get different answers depending on which one I choose. Which one is going to be better? Well, the answer is I don't want to divide by either one of these numbers. So I'm going to pick the one where I get to multiply. So let's see how that goes. I have my 47 pounds over 1. And I'm going to multiply that by, well, I want pounds to be in the denominator. And I want to choose the conversion factor where the denominator is 1 pound. I look and I see that 1 pound is equal to 0.45 kilograms. And now when I multiply, my pounds will cancel out, just like I hoped. And I'll be left with 47 times 0.45 kilograms. And nothing in the denominator except ones. So I do that multiplication. 5 times 7 is 35. 5 times 4 is 20, and 3 is 23. 4 times 7 is 28. 4 times 4 is 16, and 2 is 18. So the digits in my answer are 2, 1, 1, 5. I see 1, 2 total digits after the decimal point. So I want 2 digits after the decimal point in my answer. I get 21.15 kilograms. Notice, though, the choices that I made. I decided I wanted to use this conversion factor and not 1 kilogram over 2.2 pounds because I'd rather multiply by 0.45 than divide by 2.2. If I had divided by 2.2, I would have to do this messing around to be dividing by 22 instead. 22 goes into 47 twice, with 3 left over. 22 goes into 30 once. 22 goes into 80 3 times. 22 goes into 140 6 times, I think. Yeah, 6 times is going to be what we get. Oh, and now I see remainders repeating. The 3, 6 is going to repeat. Every 80 is going to give me a 3, which is going to give me a 140. Every 140 is going to give me a 6, which is going to give me an 80. Notice, these are a little different. Because of the way that these are rounded, we're always going to get slightly different answers depending on which one we use. But we should choose to use the one that makes the arithmetic easy. Now, look at how these tables are labeled again. US to metric, metric to US. In this problem, I started with a US unit and I wanted a metric one. I ended up choosing the conversion factor that came from this table. So when we're looking in a table like this, if what we have is a US unit, we want to use one of these guys. If what we have is a metric unit, we want to use one of these guys. Let's see another example and then I'll have you try one. Let's say we want to convert 25 liters to a suitable US unit. Well, we want to start with liters and get one of these guys. So I could get fluid ounces, I could get pints, I could get quarts, or I could get gallons. Which one should I choose? The thing that's going to guide me is 25 is a big number. If I multiply 25 by, for example, 33.78, I'm going to get some huge number of fluid ounces. That doesn't seem so good. On the other hand, if I multiply it by 0.26, I'm going to get a reasonably small number of gallons. So I think I'm going to choose to convert to gallons. I'm going to use the fact that 1 liter is 0.26 gallons. And again, I chose this instead of 1 gallon equals 3.78 liters because I want to be dividing by liters and I would like to be dividing by 1. So 25 liters over 1, 0.26 gallons over 1 liter. I notice that liters do indeed cancel, and I'm left with 25 times 0.26 gallons. So, doing this multiplication now, 6 times 5 is 30, 6 times 2 is 12, and 3 is 15. 2 times 5 is 10. 2 times 2 is 4, and 1 is 5. Adding up, I get 650. I have 2 digits after decimal points up here, 2 digits after decimal points down here. I get exactly 6.5 gallons. Again, that's not exact. This was a rounded approximation. But 25 liters is pretty close to 6.5 gallons. I'm going to have you try one of these now. Convert 12 feet to meters, and I'll put this conversion table up. Pause the video and try this now. Alright, I see that my choices are 1 foot equals 0.31 meters, or 1 meter equals 3.3 feet. Noticing that I want to get rid of feet, I think 1 foot equals 0.31 meters is my better choice. So I'll have 12 feet over 1 times 0.31 meters over 1 foot. I see that feet do cancel, and I do have just ones in the denominator. That tells me that I chose right. If I see something else, I chose the wrong conversion factor. So I'll just have 12 times 0.31 meters. Let's multiply that out. 12 times 0.31, 1 times 2 is 2, 1 times 1 is 1. 3 times 2 is 6, 3 times 1 is 3. Adding those up, I get 2, 7, 3. 2 digits after the decimal point. I have 3.72 meters.